This is a solution to the floor wax problem using R. So we've got data from a test. This manufacturer chose 10 stores where they sold plastic containers of wax, and in a different set of stores, randomly assigned, we have metal containers, and they want to know which container sells better. So the first part is to type this data into R, and you can either read it in or you can type it. So I typed it directly. Let me show you my commands. I did this before starting the video to save some time. So what you're going to see is that I've just entered the sales for the first 10 stores, and then I've entered the sales for the other 10 stores. Now if we printed wax as is, what you will see is that there are now 20 stores, 20 rows, and 2 columns, and those should match what I have in the table over there. Now the next command I gave you allows you to enter in the materials. So let me just kind of walk you through what this says. We want material to be a factor variable, and the first 10 rows of it are going to take the value 1. So that REP, repeat the value 1 10 times. And then we're going to follow that by the value 2 10 times. Now this factor has 2 values, 1 and 2. And then I want to have these strings associated with the values 1 and 2, so plastic and metal. Now if I redisplay my wax object, you'll notice that now I have a third column called material, and we have plastic or metal. I think if I did this, let's just try this. As numeric is a function that displays this as a numeric variable instead of a character variable. So if I say wax $material, I should get a bunch of 1s and 2s. So that's the way it's stored internally as opposed to the way it's displayed. So wax $material gets displayed this way. Okay, so we can cast it as a numeric variable, that's the way it's stored, or we can display it with the value labels. Okay, construct box plots comparing the distribution of sales for metal and plastic. So we can do this with the box plot command. And I think what we have to do is list the dependent variable, tilde, the independent variable, so material, and then the data object is wax. And so here's what we see. It appears that sales are a bit higher for plastic than for metal. Now you might want to add some labels. We might want to say, what is this? YLab equals sales. And you'll see that now we have sales appearing there, and that makes the graph a little bit more readable. Okay, use tapply to find the means for both plastic and metal. So the box plots are showing that the median sales are higher for plastic than for metal. Got an outlier there. Let's see if the means tell the same story. So to do that, we're going to use tapply. And so we need the variable we want to compute the mean of. So wax $sales. Now if you look down, it's giving me some help. What is the index? So wax $material is the index, and then finally which function do I want to use? Well, let's use the mean function. So it says that we sell about, on the average, 403 with the plastic container, only 390 with the metal, and those means are quite close to the medians here, just because we have symmetrical distributions for the most part, other than that outlier. Okay, which material seems to have higher sales? Well, the answer is plastic. And that's it for this